This is Now. Now I'm going to solve this question. Implement a stack using two queues, Q1 and Q2. Okay, so we have let me draw an example. We have a stack, and let's put in 1, 2, 3, 4, 5, 1, 2, 3, 4 for now. And we need to implement a stack using two queues. So let me draw two queues. So Q, and for Q, there is it's not blocked up. So it's like this. So what do we need from a stack? So for the user, if a user want to use a stack, he may want to use the pop and push and top and size function. Pop is for them to get the top of this out, and this, and the push is to, for example, put in another element on the top of the stack. And top is just to pick the top of the stack. And size is the stacks, how many elements are there in the stack. So how to use two queues to implement these functions. And let's see, pop. So pop, how do we get this 5? For a queue, it can only dequeue from the first element. So first in, first out. So 1 is in first, so a queue can only get 1 out. So let's put this in the queue now. 1, 2, 3, 4, 5. And to dequeue, we get the 1 out. So what we want is this 5, and we cannot get the 5 directly, and we need to clear this out first to get 5. So that means we dequeue this 1 and enqueue this 1 into Q2, and then we dequeue this 2 and enqueue this 2 in Q2, and dequeue this 3 from Q1 and put it here, and continue until we reach this 5. Okay. And when we reach this 5, we can return this 5. So now, after we return this 5, this Q1 will become empty. And what if we want to pop? What did I do? We want to pop again. So this 5 is popped already. So if we want to pop again, we want to find this 4. So the 4 is here. So it's like the previous situation where we have everything in the Q1, but now we have everything in the Q2. So the same thing, we just put the rest of this out to another queue. So put this out and put it to here, and get this out, put it here, until we reach this 4. and then we can return the 4. And now this becomes empty. And now if we want to pop again, we're looking for the 3. And 3 is here. So it's just like a repetition, and we put it here and we'll put it here, and we are doing this back and forth. So to make the code clean, we can just swap the Q1 and Q2 after we found the element we want. Yeah, to reuse some code. Because the Q1 here everything else will be in here, and then this one's is empty. So it's like the old Q2, which is empty, and this Q2 is like the old Q1. So we can swap them. Okay, and so I guess we're done with the pop. And for push, we just push it to Q1. We don't need to worry about Q2 because we're going to, we have swapped the Q1 and Q2 in the pop function. So Q1 will always be the one to enqueue something. And for top, that means we just need the, so yeah, it really depends what data structure we use to implement the queues. We have 3 choices. One is using list, and list is fine, but it's just to dequeue, it has a pop 0. So that means pop the 0 item, pop the item at index 0. That is what we want, but this takes all of the time, because what it did is like 0, 1, 2. So it popped this out and shift everything else to the left. So it takes all of the time. So our second choice is the Q class in Python. And the third choice is DAC from collections. DAC means double-ended queue, and it's a general data structure for both queue or stack. So we can use the queue's behavior. Like there is a pop left, that is the DQ, QUEUE, and it also has append, which is enqueue. And this is fine too. This has the get and put. Get is DQ. Put is enqueue. So today I'm going to use the third data structure, DAC. This is my choice. Okay, so for size, whatever data structure we use, it is indexable in Python. So, I mean for top, I haven't finished top yet. So top, since all of the three are indexable, we can just use this -1 to get the last element. I mean the element and index -1, which is the element with the that you put in last. And for size, we can just get the length of the data structure we use. Okay, so now let's code it out in Python. Not that, so we're implementing a queue class, a stack class. My stack. So Q1 size is not equal to 1. So while length of Q1 is not 1. So Q2 append so Q1 the pop left. And then we can have this element, so pop is equal to Q1 dot pop left. So this will get the popped element and also shrink the size of Q1. And now we will return the popped. And okay, before we do that, if we want to pop again, we will need to swap the Q1 and Q2. But after we return, we will have no chance to do this. So before we return, let's swap them. So self.Q1, self.Q2, self.Q2, self.Q1. Okay. Self push. So next. just put it to Q1. So yeah, that's it. And for top, okay. Uh, so here we need to consider an edge case. So what if the stack is empty? So if Q1 is empty, so if not subtract Q1, then we should return none. Not yet. Shoot, what do we return? Q is empty, return nothing, and print Q stack is empty. Okay. Yeah, that's it.